Section 3.1, Functions. We're going to continue or wrap up the section that we looked at the other day, talking about functions. And I know that we had a lot of vocabulary, and kind of showing it here in this word cloud, which I made online. And there's a lot of things that really stuck out. Function and relation, whether it's a function or is it just a relation. Exactly one. That was a big key. Each input is paired with exactly one output. We had input, output, domain and range, independent, dependent. We didn't talk about as much, but more in class. A lot of words there that are kind of tough to keep track of. And so I don't want you to get too caught up in the vocabulary because a lot of them really just come down to two things, X and Y. And so I want you to make sure that you know when to keep them or how to keep them organized. So take a look at this. Just about any time we're talking about a domain, an input, an independent variable, what we're talking about is an X. All right, and so those three things, domain, input, independent, are all talking about X. Similarly for Y, if we're talking about the range or an output or something that's dependent, that's a Y right there. So all the vocabulary really just comes back to X and Y, and it tells you which one you're talking about. I hope that clears things up a little bit for you. I don't want it to be too confusing. So what's the point of having independent versus dependent variables? Well, if we go back to thinking about our function as a machine, then we have independent variables, which are connected to our domain, as an input. All right, and that goes into our machine. The machine has a certain rule, and then it outputs our result, which would give us our range, because the range is related to the output. Now, for the input, which is our independent variable, it can be any value in the domain. We have freedom, we have independence when choosing it. The dependent variable is our output, and that value depends on the independent variable. If I put in a certain number for my input, that will create a certain output. It's a cause and effect type situation. So I'm going to pick a bunch of different values from my domain, which is all real numbers. I'm going to pick some positive numbers, some negative, some zero. So let's see. Let's get a little list here. Okay, so there are some options for me. Again, they can be anything. I just pick some positive numbers, some negative, fraction, decimal, whole numbers, zero, everything. And we can generate our output, which depends on our independent variable. So our inputs are our independent variables. We have the freedom there, and we're going to get an output as a result of plugging 0 into our machine as our input. Now remember that 0 as an input, as an independent variable, as part of our domain, is an X value. All right, so when I'm talking about an input, I'm talking about X. Y is an output. All right, so in order to do this, I take my 0 and I feed it into my machine. So I'm going to take a 0 here and feed it right into the machine. And I already said it's an input, so it's going to become my X. And it looks like that's 20, but in reality that's 2 times 0. And so the function takes the 0 that I input, does 2 times 0 is 0, minus 7, and it gives me an output of negative 7. And so I'm just going to include that in my table here. Negative 7 is my output for an input of 0. So take a minute, pause the video, and just see if you can generate the rest of the outputs. You can leave your answers either as decimals or as fractions if that's appropriate. Just make sure they stay exact. So pause the video and give it a shot. All right, how'd you do? All right, so there you go. You can check your work there. I'm sure it wasn't too hard. Just a matter of plugging in and then doing some PEMDAS, multiplying by 2 and subtracting 7. I would like to point out that this is actually not completely equal. I just couldn't have access to an approximately equal sign. It actually would be negative 6.7142857, or sorry, 285 repeating. Is exactly what it would be. That whole thing would repeat. But anyways, the idea here is you can just plug in your input, you get an output, and that's all that you need to do. All right, hope that makes sense. All right, so now we're just going to discuss very quickly how do we identify, if it's not in an equation, what's the independent versus the dependent variable. The independent variable is what causes a certain effect. The dependent variable changes as a result of that. So let's look at 4 different scenarios. You're comparing the amount of time you study versus your test grade. And let's assume that this is studying for that test. Which would cause the other? Well, I would think that if you study more, that would have an effect on your test grade. If you study less, that would have a negative effect on your test grade. But the amount of time you study is what you determine originally, and then the result of that is your test grade. So I would say that the amount of time you study would be your independent variable, which of course leaves your test grade to be the dependent variable. Okay, let's take a look at another example. Cell phone, your data usage, and your number of tweets. That's not a hashtag of tweets, that's a number of tweets. And which one would affect the other? Well, more likely than not, you establish first your number of tweets that you're going to tweet, and then as a result, your data usage would go up or stay low if you're not tweeting a lot. And so I think it's pretty clear that your number of tweets would be your independent variable. Of course, leaving data usage to be dependent. All right, so take a second now and try to figure out which of the quantities in the final 2 examples would be your dependent variables and your independent variables, and come back and check your work. All right, how'd you do? So these are my thoughts. The amount that you work, the number of hours that you work, that's generally what is decided, and then as a result, the money in your paycheck would be higher or lower. If you worked more hours, it would be more. So that depends on the number of hours that you work. That would be your dependent variable. And the distance you've driven this week is something that you initially do, and the amount of gas left in your tank would be dependent upon that. Now, there are other factors involved with all these situations, but that is, if we're comparing just those quantities, what we'd have there. Now, one thing that we could do is we could talk about how one of these things is a function of the other. The dependent variable is a function of the independent variable. So to go back to our first example, we could say that your test grade is a function of the study time. The dependent variable is a function of the independent variable. For the second example, we could conclude that data usage would be a function of the number of tweets. Again, the dependent variable is a function of the independent variable. All right, you know the drill. Complete the next 2, come back and check your work. How'd you do? And so there it is. Your paycheck amount is a function of the hours worked, and the remaining gas is a function of the driving distance. Now, you could have phrased it different ways, but the idea is that the dependent variable is always the function of the independent variable. Okay, so it's a little bit shorter. I hope this makes up for the last long one, and I hope this is really clear for all you guys. Nice job.